Welcome to The Explainer. Have you ever wished an AI could be an expert on your specific documents, your data? Well, today, we're going to break down the exact technology that makes that happen. A basic retrieval augmented generation pipeline, or as everyone calls it, RAG. So let's just start with the basic problem, right? Large language models, LLMs, they're trained on a mind-boggling amount of public data. We're talking basically the entire internet. But for all that knowledge, they have this one massive blind spot. They know absolutely nothing about your private stuff. Your data is a complete mystery to them. And this creates a huge knowledge gap. I mean, think about it. On one hand, the LLM lives in this world of Wikipedia, news articles, and public books. But on the other hand, all of your most important information, your critical knowledge, is locked away in private documents, your company's internal wiki, those PDF reports, customer support logs. The two worlds just don't connect. So, how do we build a bridge across that gap? Well, that's where this really powerful technique comes into play. It's called Retrieval Augmented Generation, or RAG, and it is the absolute key that unlocks an LLM's potential to finally work with your private world of data. Honestly, the best way to wrap your head around RAG is to think of it like you're building a personal AI librarian. This isn't just any librarian. It's an expert who knows every single one of your documents inside and out, and it works directly with the LLM to find the perfect answers. So building this AI librarian is basically a three-step pipeline. First up is ingestion. This is where the librarian just gathers up all your books and notes. Next is indexing, where it creates this brilliant kind of magic search system. And then finally, there's querying, which is when you get to ask a question and get a super precise answer. So let's start at the beginning.
Okay, first things first. It's pretty simple. Our AI librarian needs access to your library. We have to feed it all the raw documents that it's going to become an expert on.
And this is that ingestion stage. It's really just the process of using these things called document loaders to pull in all your information from all the different places that might be living, whether that's simple text files, tricky PDFs, websites, or even hooking directly into databases and APIs. The key word here is flexibility. I mean, modern AI frameworks offer hundreds of these pre-built document loaders. What that means for you is that no matter where your information is hiding, in a PDF, a database, some website, there's almost definitely a tool ready to go that can pull it into the pipeline and convert everything into a nice standard format. Okay, now for what is arguably the most important step. Once our librarian has all the books, it needs to develop a kind of superpower, creating a magic card catalog. And this isn't just about storing stuff, it's about making it instantly searchable in a really smart way. But you hit a problem right away. You can't just hand a 100-page PDF to an LLM and say, go for it. These models have something called a context window, which is basically a limit on how much information they can look at in one go. A really long document would just completely overwhelm it. So how does our librarian solve this? With a pretty clever two-part strategy. First, it splits those big, long documents into smaller, more manageable chunks. Then, it stores those chunks in a very special way that makes them incredibly easy to find later. This first part is called chunking, and it's pretty much what it sounds like. It's like our AI librarian is going through every book, page by page, and creating this perfectly organized stack of index cards. Each card has just one small, focused piece of information on it. Now, this is where the real magic comes in. Each of those little text chunks gets converted into a special code made of numbers. It's called an embedding. And you can think of this code, this vector, as a unique fingerprint for the meaning of that text. So chunks with similar ideas end up with very, very similar numerical fingerprints. And this is a huge leap from old-school keyword searching. Instead of just looking for specific words, the system can now search by meaning. This is called semantic search. It's the reason you can ask a question one way, and the system can find a totally relevant passage that uses completely different words to say the same thing. It's incredible. So where do all these powerful embeddings live? Well, they get organized in a special kind of database called a vector store. This is our librarian's magic card catalog, a system built from the ground up to search through millions of these meaning-based vectors in just fractions of a second. And there's a whole ecosystem of these vector stores to choose from. You've got options like Chroma, Pinecone, Weaviate, and dozens more. They all have different strengths, for sure, but they all serve this one crucial purpose: to be an incredibly fast, meaning-aware index for all of our data.
All right, so our AI librarian has gathered all the documents and built its magic card catalog. Now it's time for the fun part. Let's put it to work and ask it a question.
So when you actually type a question into the search bar, what's happening behind the scenes? How does this all come together to give you an answer that actually makes sense and is based on your data?
It all follows this really elegant retrieve and generate process. First, your question gets converted into that same kind of numerical embedding we used on the documents. Then, the system takes that question embedding to the vector store and says, hey, find me the document chunks with the most similar fingerprints. The top matches are retrieved, and then, and this is the key part, they are bundled up with your original question and handed to the LLM. So now, the LLM has all the specific context it needs to generate a final, accurate answer that is based entirely on your data.
So let's zoom out for a second. What's the big takeaway here? What does all of this actually enable? Why is this whole process such a game changer? By augmenting a powerful language model with your own information, you're not actually changing the model itself. What you're doing is giving it the exact factual context it needs to answer questions accurately. This grounds its answers in reality, in your reality, which makes the AI personalized, factual, and frankly, trustworthy. You've basically created an expert system on your own unique knowledge base. This fundamental technique just unlocks a whole new universe of possibilities. We're talking everything from smart chatbots for your company's internal documents to sophisticated tools that can analyze your own personal research. By bridging that gap between the massive language models and your private data, RAG allows AI to become a true expert on whatever matters most to you. So the only question left is, what will you build? Thanks for watching.